So thank you everybody for being here. I'm showing you the result of a TNA we just completed a couple of days ago. We started in the 23rd of October and we finished in the 2nd of November. And this was a joint TNA. So Professor Olga Battaglia from l'Académie de Saint-Étienne was here for 10 days. She was mostly Lithia, but she was using our infrastructure remotely, and she was some days here, and she was using the ITIA infrastructure remotely. So both ITIA and Politecnico have been involved in this TNA, and the subject of the TNA is something we have been working together with Polytechnic and ITIA, and this is devoted to the use of visualization in the design of a manufacturing system, and in particular we focus the activity on the transfer lines because Professor Olga Battaglia did a lot of research in mathematical approaches for the optimal configuration of transfer lines. So the idea is that every time you have to design a manufacturing system, you have to take into consideration a large number of components, many constraints, and also many actors that are different engineers addressing different aspects of the factory, and those engineers has to work together to provide a final consistent design of the factory. And moreover, every time they work, they have their own software tools, their own data structures, and one of the issues is being able mixing everything together in order to have a coherent representation of the whole factory. And we have been addressing this problem because from our point of view, it's really important not only in the early design phase of the factory, but as long as digital tools are more and more used also during the life cycle of the factory, having a representation of the data that can be used as the support for different software tools and approaches to operate their analysis during the whole life cycle, it's really important. So in the early stage of the design, you just take the information about the building, the machines you can use, the product and the process information, and what you try to do is define the layout of the system, also selecting the equipment you need to provide the requested production performance. Well, this is the early factory design. Then you go much more into details. You also work on refining and fine-tuning the processes and so on. And every time you do something in this direction, you always use some tools that could be software or mathematical or an algorithm that take into consideration the data and provide some results. And in this case, we consider an industrial application where you have to design the transfer lines, and so usually you have a process, and the process provides you the way you can access the parts, because since this is a machining process using a specific tool and a specific part program, you have to guarantee that within the transfer line the tool is able to execute the manufacturing operation without problem and without interfering with other parts of the machine. And then you have a mathematical model that usually provides you a line configuration, where with line configuration we mean the fact that you have different stations. In different stations you have to allocate some working unit, and the different working units are assigned specific set of operation in a specific order. And this had to cope with two different aspects. One aspect is a visualization that provides you the layout, so that you can organize the whole factory, not only the transfer line that stands there alone, considering all the other constraints like the auxiliaries, the available space, the routing of the parts and so on. And sure, you have also the problem of checking whether the provided production line configurations matches the performance that you are expecting. And so the idea was using a performance evaluation tool, in particular a simulation model, to get an idea of the performance of the line. And all those tools have to work together, grounding on a descriptive model of the factory as a whole. And this was the idea, and this has been addressed using an approach based on ontologies. So you need a representation of the knowledge in a factory, and you want to replicate this representation among the different tools, and moreover, the different tools often needs a subset of the whole information. So when you work using a kinematic model of the operation, you need a specific set of data, but you don't care about the processing times, you don't care about the energy consumption, as an example. When you work on visualization, you just want to know where the machine is, which are the routing, how big are the paths. You don't care about the performance, but when you work on simulation and mathematical meta model for line configuration, you need aggregate information about the process, but you are really interested in the processing times and the constraints that will give you the performance of the transfer line. So we use an ontology-based approach considering two sets of meta models. One is called the T-box, that is the kernel of the whole data structure, and provide general assumption about how the factory works, how the resource works. So a T-box contains classes that represent general concepts like machine, resources, a product, process, and so on. And then every time we have to add a layer containing specific information for the different tool we are using, we use the A box that provides individuals, specific individuals with specific characteristics, and we use this characteristic to drive the analysis of the different tools. So everything should work together, and we use the virtual factory framework to allow the connection of different tools sharing the same data knowledge and the same representation. So actually we have a data knowledge layer containing all the information, and we provide an organizational layer to these ontologies that allow you to look at the data with a specific representation of the knowledge, so thus enriching the simple information contained in the data through a knowledge representation structure. And then through this layer, we provide different tools the access to this data. So in this case, we provide access to the transfer line configuration tool that been provided by Professor Olga Bataya, and we use Arena as a discrete event simulation tools, and we use Jove as a three-dimensional environment to design the layout. While we use this virtual factory data model because thanks to this virtual factory data model, we were able to provide this A box and T box environment. And so every time we have to model something within the factory, we have a set of classes into the ontology, and those classes usually refer to already established standards. So every time we have to deal with the process, we use this ontology classes that represent step and C classes. Every time we have to work with building or something related to the environment, we use some ontology classes that are based on industry foundation classes. And every time we have to work with the process and the link between the process, the machine, the product, we refer to the ISA 95 standard. So the idea is being able to mixing together different specialized standards to provide an overall representation of what is happening in the factory. And so, as I said before, we use a Hontogai graphical user interface to insert the data related to the process, the different manufacturing operation, the processing time, the machining direction for all the machining work step. And we use Arena simulation. In particular, we use a piece of software that is able to drive Arena to simulate what is inside the ontology. and this was developed by Politecnico di Milano. And we use some mixed integer programming tools for the production line configuration, and those tools were developed and provided by Professor Olga Battaglia. And we use Java Virtual Factory in this visualization environment for 3D, and this was provided by ETIA CNR. And everything is joined together using this virtual factory data model, providing access in read and write to the different tools to interact together. So we start from the definition of the equipment, so the different working units that we can have inside the transfer line, the numbers of stations we can use, how big they are, how many working units they can allocate inside, and we also define the process in terms of machine working step and their characteristics. And then we write everything into the virtual factory data model, and then the production line configuration tools reads the characteristics of the process and also try to organize them into the station, addressing some line balancing and performance constraints. So what we have back is an allocation of the machining working step to the different station and to the different working unit, and also how these different working units are disposed, allocated into the whole design of the transfer line. Then, given this, we can read into the virtual factory data model and set up a simulation, discrete event simulation model that evaluates the performance and provides some key performance indicator like the flow time, the saturation of the different workstation, what is the production rate of the transfer lines, the work in progress, and so on. And then we can visualize everything in Java Virtual Factory in order to provide the designer an idea about how big the transfer line will be and what are the interaction between the transfer line and the different other factors within the line. So here I'm showing you some screenshots of the different tools. So this is the Honto guy, where you can see we have a specific part type with different set of operations that needs to be executed, and we have the definition of the precedence relation between the different operations. Have to say that for transfer line there are some additional constraints, meaning that sometimes it's requested that two activities are not executed into the same station due to the fact that they can disturb themselves, or they need to be executed on the same station during some tolerance constraints. And here we can provide all the information needed for the process and also on the capability of the resources. And then we use Java Virtual Factory in order to provide an idea of the layout and define all the remaining parts and remaining elements into the factory. And both those tools are developed by ETIA CNR, and Dr. Walter Turkai is the reference for this. And then we have a so-called Arena connector. So this is a piece of software that looked into the repository, so look into the ontologies, understand what are the data inside the ontology and what this data means, and then grinding on some API provided by Arena, it's able to automatically generate the simulation model, run the simulation experiments, and then collect the data, analyze them, and provide back the results into the virtual factory data model. Well, needless to say that we are able to do this automatic generation only for a specific set of production system architecture. So transfer line is one of these because the routing is already predefined and is really important in order to be able to automatically generate according to the script a discrete event of the model of the system. If we work with different kind of production system, so job shop, flexible manufacturing system, assembly system, this is not always the case. So if the routing are much more complicated, we are not able to automatically generate, but for specific case, and this is one of them, we are able to do it automatically. This is really, really fast. And those are the results. So, I mean, the plant was empty, but we working on building some 3D representation of the different station of the transport line according to the indication and the different available resources that were indicated in the use case that we took into consideration together with Olga Battaglia. And this is a more detailed picture, and it's not easy to see, but the different stations have different tools mounted, because according to the different allocation of resources on the working unit, we have different tools that perform different operations together. And so there is a different way of rearranging those tools in order to match the different operations that have been allotted grounding on the model provided by Professor Labattai.